All right, everybody. This is 10.5 implicit differentiation. So implicit differentiation means that, well, we've been taking derivatives of explicit functions so far, meaning y equals x, y equals 2 minus 3x squared, y equals, right? It's what we've been used to. It's what we've been used to our whole life. So implicit differentiation says, hey, well, if you are given a complicated equation, there is no need to rearrange it, solve for y, and then take the derivative. Implicit differentiation says, just take the derivative as is, and then solve for the derivative y prime. So that's all it wants. It doesn't, you don't have to rearrange it. That's what it means. So explicit is always y equals. Implicit means that the equation is now in terms of x and y. Explicit means y is in terms of x. Implicit means the equation's in terms of y and x. There's a slight difference there, right? So if you see the first equation given, that's explicit. Everything we're used to. Y equals x. Y equals 2 minus 3x squared. But let's say we wrote it implicitly, which is down below. Now, this is implicit because x and y, the equation is now defined by x and y, and the equation is not y in terms of x, as above is, right? Okay, so if you have an implicit equation, well, implicit differentiation says, take the derivative with respect to x on both sides, and then apply the derivative to all the terms, take the derivative, and the derivative of 3x squared is just 6x. The derivative of y with respect to x becomes y prime. And of course, the derivative of any constant, any number is always 0. So we end up with y prime equal to -6. So our job is to solve for y prime. So that's our goal for today. Solve for y prime. And we do not have to rearrange the equation into an explicit format to do so. We can just take the derivative as is. That's all implicit differentiation does. It says, hey, make your life easy, make my life easy, just take the derivative. Okay, down here is the key we are going to be following. So these are the implicit derivatives of y. The implicit derivatives of y. So if I said, so take this, and I'll just translate it up here. So if I said d over dx of y, this becomes y prime. D over dx of y squared becomes 2y y prime. And then d over dx of y cubed would be 3y squared y prime. And then we can make one more important property for any other power. We can say d over dx of y to the nth power will become, checking myself more room, will become n times y to the n minus 1 times y prime. That's it. And we will follow this key throughout the whole notes. So let's get started. And that is the implicit derivative of y key or legend. You can replace it with any other variable other than x. So if I had d over dx of z, that would be z prime. If I had d over dx of t, that would be t prime. D over dx of whatever other letter you like other than x will be something primed. That is an implicit derivative. So let's try it out. Number 1 above, we want to find the implicit derivative, solve for y prime, and then evaluate it. That's it. So in order to start these, what we do is we apply the derivative with respect to x on both sides of the equation. So I would say d over dx of 5x cubed minus y equal to d over dx of 1. Now, take the derivative of 5x cubed, and the derivative of 5x cubed is 15x squared, minus, take the implicit derivative of y, which we just learned above. The implicit derivative of y with respect to x is going to be y prime. And the derivative of 1 is 0. Now, all we have to do here is solve for y prime. Just add it over. And we are good. We get y prime equals 15x squared. The next part says just plug in the point 2, 4 into the derivative. Okay. So we would say y prime at the point, what's the funny notation? So it's y prime, and then you evaluate it at the point 2, 4. So this funny notation means we're just plugging in 2, 4. I'm probably not going to write it every time, but this is the notation that my math lab puts. I'm just not liking that. One moment. There you go. So remember, a point is x, y. So this says plug in x for 2 and plug in 4 for y. Well, we don't have a y value. We have a y prime, but we don't have a y. So all we do here is take 2 and plug it in for x. That's it. So this would become 15 times 2 squared, which would give me 15 times 4, which is 60. That's it. That's all we had to do. Maybe I'll keep writing this notation. All right, so once again, take the implicit derivative with respect to x on both sides, solve for y prime, and plug in the numbers you're given. That's it. Two, same exact thing. We'll say d over dx of y squared plus x cubed equal to d over dx of -4. Okay, now take the implicit derivative of y squared, and if you look at the top of your paper, the implicit derivative of y squared is 2y. Right for me, there we go. 2y, y prime, plus the implicit derivative of x cubed is 3x squared, equal to the derivative of the constant, which is 0. Okay. Now just solve for y prime. Subtract the 3x squared to the right side. You get 2y, y prime, equal to -3x squared. Divide by 2y, divide by 2y, and y prime is equal to -3x squared over 2y. That's it. Now just plug in that point we're given above. So y prime at the point -5, 4. And hey, look at this. We actually have a y value this time in the denominator, or just a y value at all in the derivative. So -5 is going in for x, and 4 is going in for y. And now just simplify. I get -3 times 25, so -75 over 8. And that's it. Nothing crazy. All right. Again, same thing. Say d over dx of y squared minus y equal to d over dx of 4x. Let me check something really fast. Okay. And then take the derivative. Take the implicit derivative on the left side. So once again, if you look at the key or the legend we made at the top of the first page, the implicit derivative of y squared is 2y prime. Minus the implicit derivative of y is y prime equal to 4. Now, after you take the implicit derivative, you must solve for y prime. And here's where your algebra skills come in, because we have 2 y primes on the left side. This means I have a greatest common factor of y prime. Factor out of y prime. And that'll leave me with 2y minus 1. Now, all we have to do to solve for y prime is divide by 2y minus 1, 2y minus 1, and we'll get y prime equals 4 over 2y minus 1. There's your implicit derivative. Now we just plug in the point 3, 5. And this time, I don't have an x, but I have a y, so we plug only 5 in for y. So you'll get 4 over 2 times 5 minus 1, which will give us 4 over 10 minus 1, so 9. That's it. That's all we had to do. Okay. This one's going to take a little bit of work, because now, since this is an implicit equation, when we take the derivative with respect to both sides, I'll show you in a second, we'll keep this process the same. Apply d over dx to both sides. And now we run into a problem, because since this is implicit, x and y are both functions. So I have a function x times a function y. And if you remember product rule, the product rule is when you have the derivative, when you're trying to take the derivative of the product of 2 functions. Well, here x and y are considered functions. So we are going to have to use product rule to find the derivative of x times y. So all I want is the xy. We'll leave the 3 out for now. So we'll say product rule of xy. And this is an implicit product rule. So maybe I'll put that in there too. Okay, which means that f is going to be x, and g is going to be y. The derivative of x is 1. Now for g, this has to be done implicitly. This is the implicit part. So we are taking the implicit derivative of y with respect to x. So like everything else today, the derivative of y is going to be y prime. We're doing the implicit derivative of that one, which makes it become that. Okay. And now, let's come back and remember what number was waiting out front. That 3. So we're going to have 3 parentheses and follow your product rule. F prime g, 1 times y is y, plus g prime f, you get y prime times x, which I'm going to write as xy prime. Now the hard part is over. Okay, the hard part is over. Then we want the derivative of 2x, negative 2x, and you'll just get negative 2, equal to the derivative of the constant 2, which is 0. All right, hard part's done. Calculus is over. We did an implicit product rule. I would save this somewhere. Star it, highlight it, do whatever you have to do, right? Or I'll even write it here. The implicit product rule of x times y, if you ever see it again and want to skip this process, it's going to become y plus x y prime. That's what it becomes. There you go. And now, solve for y prime, distribute the 3. 3y plus 3x y prime minus 2 equal to 0. Move the 2 over. I could have moved the 3y over as well. Move the 3y over. And then divide by 3x. So my derivative, my implicit derivative for y prime is 2 minus 3y over 3x. 2 minus 3y over 3x. I think all we have left to do is plug in that point. I've got a 1, I've got a 3. So and I do have an x and y. I have an x this time, so we'll plug those in. 2 minus 3 times the y value of 3 over 3 times the x value of 1. And that gives me 2 minus 9, which is negative 7 over 3. All right, fun stuff. So yes, remember this. It'll save you some time. All right. Do it again. Apply d over dx to both sides. And we have to stop ourselves again because we need another product rule. You're like, oh, come on. You have x squared times y. So this is another implicit product rule. So this means f will be x squared, g will be y, f prime is 2x, and g prime is y prime. Because again, this one's the implicit derivative, which becomes that. Okay, that wasn't bad. And there's no number out front here either. There's a 1, but there's nothing to distribute back. So this one's actually going to be handled a lot nicer. So we start by following our implicit product rule. F prime g, 2xy plus g prime f. Y prime times x squared, I will write as x squared y prime. And then minus, we got x cubed up there. The derivative of x cubed is 3x squared. And the derivative of -5, 0. Okay, it's done. Well, it's not done. We have to solve for y prime, but the derivative is done. From here on out, it's algebra. So if you see this, the implicit derivative of x squared y, here, is 2xy plus x squared y prime. Save that somewhere, and it'll save you some time. Okay. Excellent. Just making sure we're all good. Now we solve for y prime. And I want y prime by itself. So this means I'm moving over the 3x squared and the 2xy. They're both getting moved to the right side. So x squared y prime is going to be equal to 3x squared minus 2xy. Divide by x squared. Divide by x squared. And we get y prime is equal to 3x squared minus 2xy over x squared. Okay, I do see another chance to simplify here. I didn't see it on the other ones. In the numerator here, I see you have an x squared and an x. Let's factor out an x. If I take an x out, I'm left with 3x minus 2y over x squared, which means this x and that x squared will reduce. So this x is gone, and that x squared is gone. So we're left with our final answer of 3x minus 2y over x. So just some things to notice in case it does ask us to super simplify. All right. And then, of course, plug the number in. So you'd have y prime of 2, 4. And plug in 2 for x and 4 for y. And you'd have 3 times 2 minus 2 times 4. all over 2. We get 6 minus 8 over 2. Negative 2 over 2. Hey, look at that. We get negative 1. Hey, that worked out nice. Finally, a whole number. 6 minus 8, negative 2 over 2, and negative 1. Okay. Perfect. Last one. An application. The demand X is the number of items that can be sold at price P. For X equals P squared minus 4P plus 1200, find the rate of change of P with respect to X by differentiating implicitly. So this just says, take the derivative with respect to X, meaning do everything we've been doing today. That's it. So we'll say d over dx of X equal to d over dx of P squared minus 4P plus 1200. Okay. On the left side, that's easy. The derivative of X with respect to X, that's just 1. On the right side, it's going to sound funny. Okay? So just imagine that these are y squareds, and that's a 4y. So I said it earlier, you can just replace any other variable, and you'll still get your primes. So the implicit derivative of p squared with respect to x is going to be 2p prime. And then the derivative of negative 4p with respect to x is negative 4p prime. And guess what the derivative of 1200 is? That is still 0. All right, all we have to do now is solve for p prime. So you have a p prime here and a p prime there, which means you have a greatest common factor of p prime. Factor out a p prime, and you're left with 2p minus 4. Yes, you could have took out a 2 as well, but that wouldn't do us any good because you would still have to divide it off. So the best thing to do is just get p prime. Any prime, get it by itself. Don't even worry about factoring a number with it. Just get the prime by itself. So we factor out p prime, and we have p prime times 2p minus 4. And all we have to do is divide by 2p minus 4. And we get our answer as 1 over, I don't need parentheses, I don't think so, of 2p minus 4 equal to p prime. And that's all it wanted. Okay, that was implicit differentiation. And we are going to use something similar on the next lesson, in the next section. On 10.6, I think it's called, related rates. But other than that, this is implicit differentiation. Just remember to follow this lovely key up here. So the implicit derivative of y or any other variable other than x is going to be something primed. So once again, if it was d over dx of g, it'd be g prime. D over dx of a prime. So just choose any letter you want other than x. Because if you say d over dx of x, well, that's what we did here. You're not going to get anything primed. You're going to get 1 because the derivative of x with respect to x is 1. The derivative of p squared with respect to x is 2pp prime and minus 4p prime. So that is implicit derivatives. Harmless, right? See you at the next one.